Documentation for collision in ImpactJS. So collision detection in Impact is done in two separate steps, static collision and dynamic collision. So static is entity versus world, and dynamic is entity versus entity. Static collision is resolved by the entity itself while it's moving, and the entity checks if it can move where it wants to. Before the entity moves, it does a trace from its current position to the destination. The game's CollisionMap answers with a trace result that states if and where there was a collision. Dynamic collision is resolved after all entities have moved. Dynamic collision only checks if two entities are currently overlapping, and if so, moves them apart. It's important to note that static collision is always accurate and frame rate independent, while dynamic collision is not. This means the fast-moving entities can never move through walls, but a collision between two fast-moving entities might remain unnoticed. Impact always maintains a minimum frame rate of 20 frames per second, so that all dynamic collisions are still adequately accurate. See ig.timer.max step. Alright, static collisions. So by default, all entities will collide with the game's collision map, and the entities update method calculates the movement speed based on the entities. So by default, all of the entities will collide with the game's collision map, and the update method calculates the movement speed based on the entity's property, and then it does a trace against the collision map. And the result of this trace is handled by entity's handle movement trace method. So if you want an entity to opt out of static collision, the easiest way to do this is to overwrite the handle movement trace method for this entity with the following. So we have handle movement trace, which is a function that takes the response and this completely ignores the trace result and always moves the entity according to its velocity. Okay, so we basically are just going velocity times the system tick, and that's the new position. So we're ignoring the collision trace, if we like. Okay. You can also check with which tile the entity collided and act accordingly. So if you have tiles that are slippery, and if you want to play a sound when your player hits the floor with a certain speed, you can overwrite the handle movement trace and check for collision and speed. So for example, if the result.collision.y and the velocity is more than 32, then maybe you want to play a bounce sound and continue resolving the collision as normal by calling this .parent of res. All right, easy enough, right? You can use the Weltmeister to create a collision map. By default, the game's load level method assumes that a layer named collision is the collision map for the level. And you can always create a collision map manually. So here you have defined a map. It's a 4x3 with the two middle tiles having a collision. So you've got a wall in the middle here. And this .collision map is a new ig.collision map of 8, map. So I'm assuming 8 is probably the tile size. Maybe I can find out what is in the ig.collision map. Let's go see the docs. Okay, let's go see collision map. Here is the constructor. Yep, so that's the tile size, and then the data and then tile def. I don't, that's new. Specifies the tile definition to use. This defines which tiles are slopes, etc. The default is default tile def pass an empty object to only have solid or non-solid tiles. Okay, so we'll come back when we go over the references. But basically, we are defining the tile size and the data. The data is which tiles are being used for the collision. And doing a trace is basically doing collision.trace on that collision map and saying x, y, vx, so basically the position and the velocity in both x, y directions and the width and height of the object. And if there's a collision, then you can act accordingly. The trace collided with the map at result.position.x and result.position.y. All right, let's go back to our collision documentation that we were reading. So dynamic collisions, entity versus entity, is a bit more complex because an entity can have one of several collision modes, and if two entities collide with each other, the collision modes of both of them determine if and how the collision should be resolved. The collision mode is specified by the .collides property, and by default it's set to never, ignoring all collisions no matter which collision mode the other entity has. The other collision modes are light, passive, active, and fixed. All right, so this is important here. Light, passive, active, and fixed are the different dynamic collision modes. If a passive entity collides with an active entity, the collision will be resolved by moving both entities apart. The same is true for active versus active collisions. So if you basically collide with an active entity, then both entities will move apart. The reason that there is a passive mode is the passive versus passive collisions won't be resolved at all. They will just overlap. And this can be useful for enemies that can move through each other instead of blocking the way. These passive entities will still collide with active entities. The two other modes effectively define a weak and strong entity for each collision. In these cases, only the weak entity will be moved to resolve the collision. Okay, so so basically the light is the weak and the fixed is the strong. So essentially we have weak, passive, active, and strong. And weak is an entity that has light collision is weak, the entity that moves. An entity that has the fixed collision is strong, and it basically stays put. So basically, if two entities collide and one is light, one is fixed, the light one moves, the fixed one stays, right? Light entities only collide with active or fixed entities. Fixed entities will collide with light, passive, and active entities. So light entities cannot really collide with passive entities, is what this is basically saying. Still confused? Here's some general advice. The player and enemy character typically should be passive so that they don't collide with each other, but can collide with active entities such as crates. And platforms and elevators should be fixed so that they move regardless if another entity is blocking their path. And all entities that are purely visual and don't affect gameplay should collide light or never. So basically, purely visual stuff will just either not collide or it will get moved out of the way. The platforms and elevators are going to stay put and keep doing their thing. The player and enemy are going to be passive. But an active entity such as... So let's think about some scenarios, right, to make this a little bit more clear. So let's say that we have a player who runs into a crate. And so the player is running into a crate, and the player is passive, and the crate is active. So what would happen? If the passive entity collides with the active entity, the collision will be resolved by moving both of the entities apart. Okay, so player runs into the crate, both entities move apart, and that's how the collision is resolved. Now, if a crate falls onto a crate, both entities move apart, and that's how the collision is resolved. Now, if a player and enemy both are passive and they collide with each other, they're just going to run through each other. If I understand this correctly, right? Yeah. Or they'll just overlap. So if there's two enemies, they'll just overlap and kind of go through each other. So player and enemy characters typically should be passive, so they don't collide with each other, but can collide with active entities such as crates, so that's clear now. Platforms and elevators should be fixed so that they move regardless. Okay, so let's say that a player runs into a elevator, and this elevator is moving up and down. The player is active. Oh, sorry, the player is passive. And so does a passive... Now the elevator is fixed. So what happens when a passive and fixed collide? Light entities only collide with active or fixed entities. Fixed entities will collide with light passive or active. All right, so fixed will stay where it is. An entity that has the light collision mode set is always the weak. So I guess the player will make it into the elevator, perhaps. Because it's not a light, so it's not going to get moved. It's just not interacting, right? And I'll have to test this out. But platforms and elevators should be fixed so that they move regardless. And passive entities like players or enemies, when they'll just kind of go through the elevator. And a active entity like a crate light entities only collide with active or fixed entities. Fixed entities will collide with light, passive, and active entities. All right. And I guess there's a hidden mode of never, right? So the modes are actually never, light, passive, active, and fixed. So these are the different IG entity collides properties. All right. So I guess that's it for the documentation on collides. Let's also just quickly go back over to the docs here and check on the map and the CollisionMap classes, since we are talking about collisions. So here in the map, it is defined in the ImpactMap and inherits from IG class. So 16 tile size, and the map data creates a new map, map.setTile4028. These are basically the 40, 20 are the pixel coordinates for the tile to set. And so this essentially does 2, data of 2, 1. That is basically 0, row 2, column 1, and sets it to 8. So 40, 20 are the pixel coordinates. Why did we pick row 2? So 16 times 2 is 32, and 16 times 2 is 32. Yeah. 16 times 2 is 32. 16 times 1 is... Right, so if we go into the map by 16 at a time and we want to go to the 40, so the first 16 are going to be index 0, the next 16 are going to be index 1, and the next 16 where the 40 is going to be part of is going to be index 2. And similarly, the first 16 are going to be index 0, and the second 16 where the 20 is part of are index 1. And so the data at 2, 1 becomes 8. If I say to set the tile at 40, 20 as 8. Now gets the same tile that we just set when we do get tile, and we are saying getting the tile at 46, 18. Now again, because the tile size is 16, 46, and 18 are also the position 2, 1 for the data. And so we're essentially going to get back the same tile. And that's what this is trying to say. Okay. So that's for setting tiles and getting tiles on the map. Now, ig.map is the base class for the background map and the collision map. It only provides basic access to the tiles in the map data. You usually won't need to create instances of the map directly. So background map and collision map are the instances of the map that we're mostly going to use. And it's created using ig.map tile size data, which we saw. The tile size is the width and height of a single tile in pixels. And the data is a 2D array used as the data for this map. And properties are the dot data, which is the data and tile size and pixel width and pixel height, if you want it in terms of the pixel width and height in terms of the map. So here, I guess we have 3 by 3, so we're essentially going to have 16 times 3, which is 48. So we essentially are creating a 48 pixel by 48 pixel map by doing this here. And the methods are get the tile and set the tile. And we can get the width and height of the map in tiles or in pixels. Okay, so that's map. Let's check out the background map and collision map. So background map is basically creating a background map, which is an extension of the map. And background map is taking the tile size, the data, as well as the tile set, which is an image. So basically creating a map and also giving the specific image to pick from. And setting the screen position to 25,10. So that is to set the position of the background, and then we can draw the background. So we can create a background, set its position, and draw it. Now, in the description, it says background map draws tiles from a tile set as indicated by the 2D data array. The size of the tile set image must be a multiple of the tile size, otherwise Impact will get confused with the numbering. the size of the tileset image. Right, so basically this PNG needs to be a multiple of 8, right? Or 16 in this case. So the tile size of 32, the width and height of the tileset image could be 32, 64, 96, 128, and you can either create a background map by hand or use the IG Game class load level method, which takes the save data from the Weltmeister and creates background maps according to it. Background maps can be pre-rendered into chunks instead of drawing each tile separately. This speeds up the drawing process immensely, especially on mobile devices. However, the pre-rendered mode needs more RAM and doesn't support tile set animations. So if you want to animate the tile sets, then you can't use the pre-render. Otherwise, you can. And creating it is basically tile size data in the tile set. And it's basically starts with a 1 instead of a 0 when you number the tiles. Properties are .anims, .chunkSize, .debugChunks, distance, foreground, pre-render, repeat, scroll X, scroll Y, tiles, tile set name. Methods are draw, set screen position, and set tile set. So quickly looking through anims, we will get to, I guess, when we talk about animation sheets and animating the tiles, but here we can see that we are trying to set the tile number 5 of the background map to be animated by saying bg.anims of 5 is a new ig.animation of this animation sheet at 0.1. That's probably the timing, and then 0, 1, 2, 3, 4 are the tiles to use for that animation. So essentially it's just going to loop with an interval of 0.1 the tiles 0, 1, 2, 3, 4 from the tiles.png tiles sheet, whatever we call that tile sheet. Tile set. All right, so that's the background map. Foreground does whether this layer will be drawn in front of all the entities. Default is false, of course. It's going to go a bit behind all the entities. Distance is distance factor for the background map, indicating how fast the map scrolls when the set screen position is invoked, and with a distance of 1, the map scrolls synchronous to the screen. With a distance of 2, the map scrolls with half the speed and making it appear farther in the background. The default is 1. So the greater the distance that you set on the background map, the further it's going to appear that it's a background that's further, right? So imagine that, we are playing a Mario-like game and we have these mountains in the back. So we're going to set a higher distance. And if we have buildings that are closer than the mountains, we're going to set less distance. And if we are scrolling with where the character is, that will basically be 1, right? So as we navigate our screen, 1 will be the, right? And debug chunks, if pre-render and debug chunks are true, the draw method will draw a pink outline around each chunk. Okay, so that's just useful for debugging if you want to have a pink outline around each chunk. Chunk size is the chunk width and height in pixels. For the pre-rendered background maps, the default is 512. That's if you're pre-rendering. Anims, we talked about the animation sheet to animate tiles on the background. Scrolling X and Y, scroll position of the background map in screen coordinates with the map's distance already factored in. Should only be read. Use.set screen pose to set the scroll position of the map. So don't try to use scroll X or scroll Y to set it. Use the set screen pose. And dot tiles is an instance of the image. The tile set and tile set name is the location of the loaded tile set image. Okay. So we spoke plenty about the background map. Let's go back over to the collision map next. So we are going to go over to CollisionMap. Again, it's an instance of map, which we just talked about. So we're going to put in the data, and the collision map basically has the same signature as the map. It has a trace property, and I spoke about this in the previous introductory video, I guess. But now a description of the collision is it takes the 2D tile map and allows tracing against it for collisions. The IG game, so again, you can use the Weltmeister level editor to create the levels and then use the game's .load level method to load that collision map. And by default, you're going to want to call it collision as the name of the layer. And all the entities trace against the collision map as part of the update cycle. So the constructor, we basically have the IG collision map with the tile size, the data, and the tile definition. And we are going to take the tile size as the width and height of a single tile in pixels, and the data is the data. Basically, it's the same definition as the map. And there's an optional tile def parameter which specifies the tile definition to use, and this defines which tiles are slopes, etc. And the default is ig.collisionmap.default tile def. Pass an empty object to only have solid or non-solid tiles. Okay. So basically, the tile definitions allow you to interact differently with the different collisions, right? Is what I'm understanding. Now, the first solid tile, okay, this is removed, so I'm not going to go over it. Last slope is there in the current version. So the last tile number that is used for slopes, all tiles above this number can be used for custom tiles. The .last slope is automatically determined by the constructor through the tile def property. The methods are basically, there's just one method called trace, and it takes the position and the speed and the width and height of the object, and it traces from that given position to the new position, which is x plus the, okay, sorry, it's not the velocity. Sx is the change. So it's basically the velocity times the time, right? So like, for example, if you move from position 0, 0 to 3, 2, then xy is 0, 0. And x plus sx is 3 and y plus sy is 2. And so sx is 3 and sy is 2. For an object with the specified object width and height. So this method returns a trace result in the following form. And the trace result is basically collision, position, and tile. Collision is there a collision at x, y, and is the slope true or false? Position, resulting object position, so basically x plus sx and y plus sy. And tile, tile for the collision, so essentially where we landed up and which tile we collided with. So, and then there's also this collision slope property, which is either false if there's no slope collision, or an object with the properties x comma y minus the slope direction minus, or sorry, and x and y, the slope normal. Sorry, the dashes are kind of confusing for a minus sign. But basically xy is the slope direction and nx and y is the slope normal. Okay. So that's the collision map synopsis. All right, I think this is good enough for this video. We've talked about what collision maps are. We've talked about what maps are, what background maps are, and the actual details of the collision map as well. I will see you in the next video where we will continue going over the ImpactJS documentation.